momentum. Can everybody say momentum?
Momentum.
Momentum, very good. So momentum means is that when object is moving or spinning, it will stay in motion until an external force, like my hand, stops it. You see, it's stopped. But it is always in motion if my hand is not touching it. Okay, now for this experiment, you see how I have a cord right here in front?
Yeah.
What I want to do is, I became very curious. I thought to myself, what would happen if I put the wheel right here and then pull the cord towards you guys? Raise your hand. What do you think is going to happen? Yes.
It's going to happen if you pull it, it's not going to spin.
It's not going to spin? Oh my goodness. Now you, my friend, just made a hypothesis. Can everybody say hypothesis?
Hypothesis.
Hypothesis, very good. Now, hypothesis is a testable idea of what you've already seen so far. So let's test your hypothesis. Raise your hand if you think the wheel is not going to spin when I pull on the cord. Okay, now raise your hand if you have a different hypothesis or idea. Ooh, okay. Now this is my favorite part. Ready? Take both your hands, put them in the air, and then wiggle them back and forth. If you want me to get started. Woo, fantastic. All right. All right, now I'm going to put the wheel on the table right here.
Fun.
I'm going to hold on to the cord. And I'm going to pull from countdown of 3. Are you guys ready? Yeah. Are you ready?
Yeah.
Okay, ready? 3, 2, 1. Thank you so much. That was my show. I'm kidding. Okay, what happened? Shout out what happened.
I knew it.
Shout it out.
You pulled it off, the wheel off, and it didn't get spin.
It didn't spin, right?
Right.
But did you see it had this kind of motion?
Yeah.
It kind of swung a little bit. So it had momentum, but then it stopped. Why did it stop? Raise your hand. Why?
Because you hold it.
I was holding it, yes. And there was this invisible force that we don't usually see called gravity. Can everybody say gravity?
Gravity.
Now, the reason
gravity?
why I can't jump off of this stage and fly all the way out to Hawaii is because of gravity. So I am forced to buy a $2,000 plane ticket. Gravity working against me. All right, now for this experiment, I want to change it up. Do you see how I have another cord right here? I became curious once again. I thought to myself, what would happen if I pulled on this cord and on the original cord? Raise your hand if you have a new hypothesis of what will happen. Yes, in the purple shirts. Okay. Ooh, okay, so it will fall but spin. Yes, okay, very good. Raise your hand if you think that's going to happen. I like that hypothesis. That sounds like a really good hypothesis. Raise your hand if you have a different hypothesis, a different idea. You do? Okay. Are you guys ready to test it out?
Yeah.
Okay, fantastic. Okay, I'm going to put the wheel on the table, take out the second cord. I have my hand on the original cord. All right, now friends, watch. I'm going to pull in the new cord, and I'm going to lift. Yeah! What's happening? Shout it out. What's happening? It's spinning. Do you see how it's spinning in an L shape or at an angle? This is called angular momentum. Can everybody say angular momentum?
Angular momentum.
Very good. Now, who here? Raise your hand if you ride a bike. You ride a bike? Yes. When you're riding your bike, you're actually using angular momentum to keep upright. But when you slow down, you have to make sure that your feet are on the ground because that angular momentum will go away and you'll fall if your feet are not on the ground. Now, angular momentum doesn't disappear in thin air. It converts into a different energy called potential energy, which means it's stored energy. All right, friends, are you ready for the next experiment?
Yeah!
Fantastic! All right, I'll put this away. And now I'm going to bring this forward.
A leaf blower.
Oh my gosh, I didn't have to ask what this was. Yes, it's a leaf blower. Fantastic. Okay, now friends, what is this?
A beach ball.
A beach ball. What's inside the beach ball?
Air.
Oh, very good. What's all around us in this room?
Air.
Air, very good. Now, does anyone know what air pressure is? What is air pressure?
It's when you're pushing that air in.
Yes, kind of. Yes, it's like air pushing against you. And there's different types of air pressure. Okay, here, I'll give you an example. Now, when we're traveling around the world, there's different air pressure. So if you're on top of a really tall mountain or hill, there's very low air pressure, and it feels like you can't breathe. But when you're scuba diving in the ocean, there's very high air pressure, and it feels like an elephant is on top of you. And our body tries to adjust to that air pressure by doing a pumping noise in our ears. So for this experiment, I want to get this, change air pressure. What? So what I want to do is I want to turn on the leaf blower and then put the beach ball in front of it and see what happens. However, I don't really feel like doing this by myself. I would like a volunteer who is okay with the really loud noises. If you're okay with loud noises, because this is an outside tool, that would be fantastic. Yes, in the blue jacket in the back. Come on up.
Okay.
Up these stairs, right everywhere. Woo! Yes, very good. My friend, what is your name? Hiya. Thank you so much for being a volunteer. Yes. Yes. Okay. Now first, I need you to test this. Does this feel like a beach ball? Oh, thank goodness. Oh, I was a little worried. Okay, now. Really? Okay. Oh, there we go. There we go. That feels good. Okay, so what I want to do is I want to turn on the leaf blower, but I want you to place the beach ball there and then let it go. You're not going to throw it in when I turn on the leaf blower, okay? No, not like, we're not beating it across the room. No. You're going to place it here, and then you're going to let go, and you're going to step back, okay? How does that sound? But I'm going to count down from 3. I know, it's on purpose. It's on purpose. Okay, are you ready? I'm going to count down from 3. I'm going to turn it on, and then you're going to place it in there. Don't put it on in front. You got to wait. All right, audience, are you ready to count down from 3 for our volunteer?
Yeah.
Are you all ready?
Yeah.
Okay, now, again, reminder, this is an outside tool. If you don't like loud noises, cover your ears right now, okay? All right, are you ready? 3, 2, 1! Whoa! Thank you so much. All right, friends, raise your hand. What happened when the beach ball was in the water? Yes. It was floating. Yes, it was floating until our volunteer's hand was in front of the leaf blower, and then it fell down, right?
Yeah, and I got it.
It twirled a little bit, yes. So there's many things happening, but the major thing that was happening was that we were using Bernoulli's principle. Can everybody say Bernoulli's principle? Bernoulli's principle. It kind of sounds like a noodle, right? Well, Bernoulli's principle tells us that when there's fast-moving air, there's very low air pressure, and all the air around us in this room has very high air pressure. So the beach ball was floating in between 2 different types of air pressure. Now, air pressure wants to be equal with each other. It wants to be in equilibrium. So it looked like there was an invisible tube, and the beach ball was doing this. Right? It was twirling, right? And that's because of gravity. Oh my gosh, gravity does not want to leave. Oh. Incoming. Oh no, I can't handle that. Okay, now I'm going to adjust Bernoulli's principle. Are you all ready for this? Okay, I'm going to put this away. I'll put that there. I'm going to put this here. I'm going to use this. Okay. Now, I am going to use Bernoulli's principle to make a huge balloon, but I don't really feel like doing it by myself. I need a volunteer who's really good at blowing up balloons, like super good. Yes, fantastic, come on up, over here. Yay! My friend, what is your name? Is she? All right, yay! Okay, now, my friend, I want you to hold the bag like this. Can you hold it like this? So you're gonna have it really close to your face, okay?
I thought you want to go.
Like really close, like this, like you're blowing a balloon. Okay, how does that feel? Feels good? Okay, let's just wait 2 more seconds. Let's wait. Hold on. Not too close. Okay, so what we're gonna do, what our volunteer is gonna do, is she is going to blow into the balloon 10 times, really close to her face. Are you guys ready for this? Are you ready? Yeah. Are you ready? You're gonna blow into it 10 times. We're gonna have you count, okay? We're gonna count to 10 for you. So I'm gonna say ready, set, go, and you're blow into the bag, okay? Okay, high five, you got this. Yes. Now hold that bag, have it really close. Hold on, I'm gonna pump the bag. All right. Audience, are you ready to count to 10 for a volunteer? Okay, ready, set, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now close the bag. Yes, very good. Okay, I'm gonna take this. You stay right there. I know it's a little weird, right? All right, let's see. Let's see how big the balloon is. Oh, does it look like a candy to you? Kind of. Let's see how big it is. It's kind of bigger than your head. audience, remember the size of the balloon. You got this? Seared into your brains, okay? All right, are you ready to change this up? Oh, it's gonna be good. All right, we're gonna get all that air out. And now we're gonna use Bernoulli's principle. Ooh, fancy. Okay, I'm gonna get this bag a little bit more wider. Okay, so this time you're not gonna blow into it 10 times. You're only gonna blow into it 1 time. And the bag is gonna be far away from your face. How does that sound? Good? Okay, high five. You're doing great. All right, now hold on to the bag right here. You're gonna have it far away from your face, but you're gonna blow into it really, really hard, okay? And we'll see. The INTV will say ready, set, go, okay? How's that sound? All right, fantastic. I'm gonna fix this bag a little bit, make it a little bit more presentable. Okay. Are you ready? Audience, are you ready?
Yeah!
All right, ready, set, go! One! Now close it back. Yes, very good. All right, you ready to see how big the balloon is? Let's see. Oh no! You want to try again? Let's try again. Okay. Get all that air out. You gotta blow really, really hard, and make sure it's far away from your face like this. Okay? You breathe. You gotta breathe first. Okay. Ready? Set. Go. Blow. Oh, yes, very good. Okay, let's see. Oh, no, it's bigger. You know, it's okay to fail. We can try again. Now do you see someone bigger now? Good job. Hi, but you did it. Let's a round of applause for our volunteer. You do it now. Yes, very good. Okay, now friends, do you see it's bigger now, right? Because we were using the nose sprinkle. So what happened was is that the bag was far away from our volunteer's face, and she only blew it into it 1 time. So the breath was that fast-moving air, that low air pressure, and the air around us in this room was that high air pressure rushing behind that low pressure, giving us a bigger balloon. All right, are you guys ready for the next experiment?
Yeah!
I love the energy. I love it so much. All right, we're gonna put this away. What is this? No, you're done. You're done. Okay, I'm gonna unplug this. And now I'm going to plug in this. Now, someone said it looks like I look like Frankenstein with these machines behind me. I know it was you, but it has a name. This is called the Van de Graaff generator. Can everybody say Van de Graaff generator? The Van de Graaff generator. It makes electricity, specifically static electricity. So here's an example. You take off your shoes and you rub your socks on some carpet and zap your friend or sibling. Have you done it? Oh my God! Don't worry, I'm going to. So that's static electricity by zapping of that, rubbing of your feet on the carpet. So that's what this machine is going to do. So for this experiment, the first experiment, I'm going to touch it. Raise your hand. What do you think is going to happen when I touch the machine?
You're gonna get electric shock.
I'm going to get electrocuted?
You know when mommy touched you? Just like
I don't like that. What's going to happen?
Nothing's gonna happen. Oh, God.
Yeah, that's the thing she explained right now.
Okay. Okay, raise your hand if you think I want to get electrocuted. Raise your hand. Okay. Raise your hand if you think nothing's going to happen to me. Nothing's going to happen to me? Okay. Let's test this out. Okay, ready? You guys ready for this? 3, 2, 1.
I was right.
Yeah, you were right. I didn't get shot because it's not on. The machine's not on, you guys, if you can't tell. Now, if I touched the Van de Graaff generator while it was on, I would have had a huge shock to my body because it's that buildup of static electricity. Now, buildup of static electricity involves these charges. And by that, I mean these negative charges and these positive charges. It's a buildup of only negative charge. And when it's this buildup of the same charges, they don't like each other. They want to repel. They want to go away from each other. So this is what happens in this box. I have one negative charge that goes, excuse me, this is my house. The other negative charge goes, no, this is my house. And then I have to go, why are you guys being so negative? Like, oh my gosh, those negative charges. So in order to touch it safely, I'm going to use this. Shout out what this is.
A towel.
A stool. What is the stool made out of?
Wood.
Not wood.
Plastic.
Plastic. Yes, very good. Now the one and only good thing about plastic is that it's an insulator. So when I have electricity in my body, it will stay in my body and I won't get electrocuted as long as I'm on the plastic. Are you guys ready to see what's going to happen? Okay, fantastic. I'm going to put the stool down. Let's step on the stool. I have my hand on the Van de Graaff. Now I promise I will turn it on. Are you guys ready?
Yeah.
Okay, 3, 2, 1. Oh, yes. It's on, you can kind of hear it. There's a rubber band going around, piece of carpet in the box, all that jazz, you know. What do I right here? It's sticking up? Are you telling me I've been having a bad hair day this entire time? And you didn't tell me? Oh my god, oh gosh, okay. In my defense, I think I look like Albert Einstein. If you know that picture, then I feel radical, okay? Just saying. Okay, you guys want to hear about the science behind why my hair looks so cool? Okay, now what's happening is the buildup of static electricity. It's going in my body, it's going here. And it's trying to leave my body, but it can't because I'm standing on the plastic stool. Watch this. If I take this side of my hair, if I try to touch the other side, do you see how they don't want to touch each other? Yeah. It's those same charges repelling each other. They don't like each other. But they can't leave because I'm on the stool. Okay, now friends, raise your hand. What do you think is going to happen when I let go of the machine? What do you think is going to happen? Yes, in the back. I'm going to get electrocuted. My gosh, it seems like a theme today. Okay, raise your hand if you think I'm going to get electrocuted. Oh, okay. Raise your hand if you think nothing will happen. Aha! I didn't get electrocuted, but what's wrong with my hair? My hair is still up. Why? Because I'm on the, what am I standing on? The stool is insulating those charges. But once I get off of the stool, all those negative charges can slowly get out of my body and go to the ground. However, my hair really likes static electricity, so watch out when I get really close. My hair will start going up again. Okay, now who here wants to see their own personal lightning storm? Okay, now if you want to see, you got to scoot back a little bit, okay? All right, I'm going to go over here. You got to scoot back, you got to scoot back, you got to scoot back. Okay, now I'm going to get this really close. It's going to be a little bit loud, so cover your ears if you don't like loud noises. I know, it's kind of like soundboard. But now, the spheres that are really close, they're now really close to each other. All those charges are now bouncing back and forth, giving us ourselves our own personal lightning storm. But now, I'm going to stop it with this. What is this? It's not exactly a straw, it's a stick. What is the stick made out of? Metal, yes. Another name we call this is a lightning rod. Alright, girls, watch this. I got it really close. Do you see how the lightning stops? So lightning, or no lightning, no lightning, no lightning. So there's these really tall buildings, like in New York City, skyscrapers. They have these tall metal rods. They're there to conduct the lightning to go somewhere else. Metal is the conductor. It's gonna go wherever metal is, so that we on the ground don't get electrocuted. And now I can kind of feel some of that static electricity coming back into my body. Okay, now for the last part of my experiment, I'm going to first turn this off. Ooh, I'm on charge. Now I'm going to use these. Okay, fun fact. Your scientists here, I have twin brothers. They are currently 15 years old. They're constantly eating everything from the fridge. It is really frustrating. But I went to the grocery store and I saw these mini pumpkin pies and I went, oh my gosh, I need to try one, but I need to hide it from my brothers because they're going to eat it. So I thought I hid them in the perfect place ever. Well, I woke up this morning to find out all these pie tins empty and all over the counter. Oh, I was furious. I was like, I didn't even get to try the pies. Oh my goodness. But then I went, hold on. These pie tins are made out of metal. I have a Van de Graaff generator and I know that metal is a conductor. So I became curious. I thought to myself, what would happen if I put the pie tin to uncover the Van de Graaff like this and then turned on the machine? What do you think is going to happen? Raise your hand. Raise it. Yes, in the back. Yes.
It will, like stop.
It will stop?
Yeah.
Like stop what? The machine?
Yeah.
Oh, the machine's just going to break? Ooh. Okay. Raise your hand. That's going to happen. The machine will somehow break if the pie tins are on top of it. Okay, raise your hand if you have a different hypothesis or idea. Oh, okay. Are you guys ready to see this?
Yeah.
Okay, fantastic. Okay, I'm going to put this on the Van de Graaff and make sure it's secured. Yes. Now it looks like it has a little bit of a hatch, right? Okay, friends, are you ready to see this?
Yes.
Okay, ready? 3,